Hello friends, today we'll discuss about the topic, the indicators of solar radiation. So we have been discussing about the solar radiation in yesterday's class. Okay, today we'll see what are the indicators of the solar radiation. The solar energy is the renewable energy. Solar energy is the renewable energy which is developing rapidly. If you observe in the recent decades, so the growth of the solar energy is very fast, and before 10 years, 20 years, you can never see a solar panel. You would have never seen, nobody can have seen a solar panel before 20 years. So now you can find them everywhere, anywhere, even in the villages, in the tribal places, where the government facilities cannot reach there. So normally what happens, if you want to electrify a village, a certain place, you need to give a transmission lines there. So this has started because of hydropower, thermal power. So there, what's happening is that the generation will be at a remote place. So if you take a hydropower, the generation is at a remote place, and actual load, the demand will be in the cities. So the generated power has to be transmitted to so many kilometers, thousands of kilometers away from the place of power generation, and it has to be transmitted there, and it has to be distributed properly. So there we are using our transmission techniques. So we are upgrading. We are doing step up with high voltage, because to reduce the I-square or losses, and so afterwards we are again step down, and we are utilizing to our domestic or industrial or agriculture purpose or commercial purposes. So different case. So there, that is case, and if you are using thermal power, that is, you can use somewhat nearer to the places, towns or cities, towns or cities. So that is a thermal power station. So here what we are doing is that we are generating power, bulk amount of power, and supplying, and we are supplying to the demand where the places where the demand is there. So that's why it is, they are integrated, grid connected. We'll be having a national grid, state grid. So that is a grid connected. But if you want it as off grid, so that is not that much of comfortable as the wind energies and solar energies. It's not that much of comfortable as that of wind energies and solar energies. So here these are one thing is these are renewable energies, and we can install anywhere to whatever the capacity you need. For example, hydropower you cannot install anywhere, everywhere. You cannot install everywhere. So there are some geographical constraints of this power. And similarly for thermal power, so you need to produce in a bulk way for this process. So the advantage of this renewable energy is whatever you are saying, especially about the wind energy and solar energy, is that they are portable. They are very much portable. So of course you may find you are able to see these power stations in a huge, very big power stations. Okay, that is for the bulk supply. But if you want to use them as a standalone systems, so they are very much suitable than our traditional methods of power generation. These are portable. So you can generate. So wind energy to some extent, it has seemed that it's not that much of portable. But nowadays, we are able to produce wind turbine. We were able to generate wind power in small amounts. We are able to produce very small wind turbines, which may be just suitable for a house. So there, what is happening is that they are able to capture the small winds. See, actually, if you want to, olden days, so why we are actually going for very big wind turbines is that, so you can have a less production cost. So that's why we are going for a huge power stations, a vast power station. I mean turbine, maybe a solar turbine, solar energy. So that's a thing there. There, what happens is that if you are going to that much of huge turbines, even nowadays we are going to even to the offshore wind turbines. So where you can, we don't have the problem of land. You don't have the problem of land, and you can transport very big turbine pots in the ships easily when compared to the land. So that is having. So there we are going to very huge turbines, huge windmills, because uh, the cost of production will decrease. So, but if you want to use it for a standalone, simply if you want to use it for a charging purpose for a laptop, only for that is enough. The amount of power which is required for charging a laptop or a cell phone, so that we cannot do it independently. If you go to the hydropower or if you go to the thermal power, wind power also somewhat. So solar power is very very portable. Even we can go for the remote places, and sun energy is available everywhere. So, but some revolutions are happening in the wind energy also. They are coming with the turbines which can capture low speed winds also. So generally low speed winds in towns you can find. So cities and towns you cannot find high speed winds because of the constructions. So like that, that is happening. So here, mm, if you uh, compare in that, if you think in that way, the solar energy is much portable. You can just carry a solar panel and you can use in anywhere. So that is the benefit, and that's why we have started discussing. Yes, okay, the dark side. Or we have in our previous classes we have discussed about the dark side of the solar panels. So during the generation process, we really don't have any pollution problem. The problem is that we are having while producing the solar cell, which is made up of silica, the same amount of energy is needed. Again, this energy we have to supply from a hydropower or thermal power. So the plant which is making solar cells, maybe whatever may be the technology, monolithic or monocrystalline or polycrystalline or thin film technology, whatever it may be. So it needs it absorbs so much of power. Again, this we have to supply from at present, again, this we have to supply from the hydropower. So, um, and during the process, the same amount of pollution which is released for making a computer chip, is released along with after that its decomposition is also dismantling. So we are using so many heavy metals there, precious metals in the process of making a silicon. And plastic, huge amount of plastic you are using. So recycling is a big process. Okay, that is a dark side of the solar energy. And so here is, we have discussed in our previous classes about the energy of the sun. So what is the place of the sun? What is the place of the sun? Um, if yes, simply we can say, so if the sun is not there, even our Milky Way is not there, that's not going to be a show effect in this infinite universe. And there are so many Milky Ways which are very large and very small than our Milky Way. And but if you come to our sun, that is our star, our family, yes, our sun is not that much of very big sun or a small sun, so it is average. Caris Majoris is the biggest star we know up to now, and there are some small stars where the planet is bigger than that sun, that star. And our sun is not a young star or a old star. It is in the middle. And that is, so you know how a star is made up of. So many people know. Star means it is having a huge amount of light and heat. Yes, it is a mixture of majority of hydrogen gas and helium gas next, and only 1% of some other materials. So the process, the fission process is occurring there. Nuclear fission is occurring there. How it is, how, which force is making to uh, come closer like that? So that is the dark energy or dark matter. So these are the invisible forces which are the cause for this expansion of the, yes, of course, Big Bang. After that they are staying, it's expanding. And which force? If something is expanding, there should be some force. And okay, that's a different case. So when we have discussed what are the various layers of the star, of the sun. Corona, what is corona? Visible corona, which is crown shaped, which we can see during the eclipse. What is at the core, under the layers, magnetic belts, alpha rays, gamma rays, all these things in the core. Okay, because of that uh, that fission reaction, so much of light and heat energy is released, and it's reaching to the planets. It is reaching to the X universe. It's moving outwards. The energy is transferring. So that's what we are calling it as radiation. So it is coming to all the planets in our solar system, but only our Earth is the planet where we are able to use it for the life, where life is there, and it is utilizing that. And so, yes, of course, that energy is indirectly, the sun is basic source of all the energies which we are able to experience. So that's a different case. And then we have discussed about how much of energy is coming to the earth at the speed of the light. What is the time we are spending? The light is sunlight is taking to reach to the earth, approximately 8 minutes. It's taking, so that we know we have discussed. So this energy which is reaching to the earth, so 50% is absorbed by the earth's atmosphere, and remaining 50%, approximately 50%, is absorbed by the earth's atmosphere. Only 50% is reaching to the earth. 50% is reaching to the earth. So here, in that 50% also, only 21% is the direct rays of the sun. Remaining percentage, 29% is diffused energy, diffused sun energy, so which has passed, which has affected by the atmosphere. Okay, so remaining some is reflected back to the space, and some is absorbed totally by the atmosphere. So remaining also only 20% is direct sun rays, direct energy from the sun. So remaining thing is uh, altered by the atmosphere. Okay. That even after reaching, there are so many constraints. So depending on the area of the land, okay, the land property, whether it is a desert, whether it is a good land, it's varying. Again, the capacity is varying. So based on the location, latitude, longitude, and based on the season, and based on the time of the day. So those things we have discussed here. So that is, we have seen what is azimuth angle, what is incident rays. So all these things we have discussed in our previous class, and actually we will see. So what are the instruments? So this much amount of energy is coming. We have to measure it. So we have, before that we have discussed some important terms of that solar energy, of measuring that solar energy. See, tilted surface. So solar radiation on a tilted surface. So actually what happens? So if the sun rays is exactly perpendicular to the panel or a PV cell panel, you will get a very good energy observation. But what actually happens? That exactly perpendicular falling of rays on a solar panel, it will last only for some time. If it is a fix, normally majority will fix it. We will fix at some angle and we will leave that. So majority you are not going to get a perpendicular falling of the sun rays. So that will see. So the power incident on a PV module depends not only on the power contained in sunlight, but also on the angle between the module and the sun. So that is module is a sun rays. So generally module will be like this. So if the sun rays is exactly perpendicular, so it's a very good thing. But most of the day it will not happen. So during the sunrise it will be like that. Slowly it will come. At some point it will come perpendicular, and afterwards again it will move. So again it's going to, that position is going to change. And so that's why. So the power incident on a PV module depends not only on the power contained in sunlight. So it is not only depend on the power of the sunlight, but it also the angle between that module and the sunlight. So when it is exactly perpendicular, okay, it will get. But what happens? It will be continuously changing. The angle will be continuously changing because the sun is continuously moving. The sun is continuously moving. So the amount of solar radiation incident on a tilted module surface is a component of the incident solar radiation which is perpendicular to the module surface. So that is the component. So that is the component of the solar radiation on the incident on the perpendicular module. So we will see what is this modules. Okay. So here, if you observe here, see this is the sun rays actually falling. So this is the actual perpendicular line. This has to be there. So this is the horizontal plane. This is the array. This is the array. And how we are going to get the total thing is the S module is equal to S incident, that is sine alpha plus beta. So what is the actually thing is, you should have from this angle, so here to here, this is beta, and this to this horizontal line, this is alpha. So the total will give the S module. So S horizontal is equal to S incident into S alpha, where alpha is the elevation angle. So this is the elevation angle. And beta is the tilt angle of the module measured. Beta is the tilt angle. How much tilt? So this is horizontal. What is the tilt angle? So this S horizontal will give the S incident to sine alpha. S module is the sine incident into sine alpha plus beta. So including that, we have discussed about azimuth angle, all these things, incident angle, and tilted surface. So always tilted surface. So only at the time it is perpendicular, you will get the maximum thing. See, generally, how much amount of energy we got, we are having certain measuring devices for that. Okay. So generally, we are going to use a pyranometer, pyheliometer, and pyheliometers. So one is diffuse. So it is global or diffuse radiation. It is able to capture the global or diffuse radiation. So that's why it will be half cylindrical shape. And another thing is straight. It is direct incident rays. Another thing is going to take the direct incident rays. So first thing is the pyranometer, which is used to measure the global or diffuse radiation. A pyranometer is designed to measure global radiation, usually on a horizontal surface, but can also be used on a inclined surface. Generally, we will select a horizontal surface generally, but some cases where it is needed, we are going to use it in the inclined surface. So the pyranometer also measures diffuse radiation by using shading ring. So that's why we are calling it as it is a global or diffuse radiation measurer. And pyheliometer, so it will take only the direct incident of the sun. So it cannot take the indirect incident of the sun. So we are having here in this table global horizontal irradiance. If you want to measure the global horizontal irradiation, so you are going to use the pyranometer. Solar radiation on a tilted plane. So in the name itself, it is tilted. It is not direct incident. Okay, we are going to use the pyranometer. So irradiance in the plane of array. Again, arrays generally we are using the arrays. Again, we are using the pyranometer. And direct solar radiation. Here, direct solar radiation is pyheliometer. Pyheliometer and a solar track. So if it is a tracking, exactly. So the sun angle changes, so it will move such that the rays are perpendicular to that module. So there we are going to use that pyheliometer. Again, diffuse radiation pyranometer and albedo pyranometer and surface energy balance pyranometer. So all these things we are going to use the pyranometer. To measure sunshine hours in a day. So what are the total amount of hours, sunshine hours? So we are going to use the sunshine recorder. So basically only three equipments we are using: pyranometer, pyheliometer, and sunshine recorder. 90% cases we are using with this only three equipments we are using. To measure the terrestrial radiation, piezometry is used, and pyradiometer is used for both solar and terrestrial, extraterrestrial and terrestrial radiation. So this is actually it will be having two junctions in a pyranometer, that is a cold junction and a hot junction. So that is incoming energy, and this is the hot junction and cold junction. Here will be a measurer. So actually this will give what is the energy. So it will have, see, so this is, so at the top you can observe here outer glass dome. So why it is like this? Because it has to absorb the global radiation or diffused radiation also. So its purpose is to absorb the global, not direct radiation. That's why it has to absorb the diffused radiation. So this is the outer glass dome, and this is the thermistor. So we have to measure the temperature and compensation element. So hot junction and cold junctions you can observe here. Subframe, sensing element, inner glass dome. So outer glass dome, inner glass dome, and desiccation is there. So with this combination, we are able to measure the global radiation of the sun. So if you simply, we can say that pyranometer is a device that measures solar irradiance from hemispherical field of view incident on a flat surface. Sometimes inclined surface also. Sometimes also the inclined surface. So the SI units of irradiance are watts per square meter. Traditionally, pyranometers, actually these pyranometers we have not developed for measuring this solar energy. Actually, we are using this for climatical search and weather monitoring purposes. So after that, we have started using this for measuring the. We have used it for measuring the solar global radiation or irradiance or diffused radiation. So that's so pyranometers measure global irradiance. Okay, the amount of solar energy per unit area, per unit time. So if you take a unit area, so in that area, what is the amount for a unit of time? So it is so a hemispherical surface it is having. So the global irradiance means that is direct sunlight and also the diffused sunlight. So it is direct sunlight plus diffused sunlight it will give. So if you want only direct sunlight, you have to go for high heliometer. If you want here, you will get only global light. So combination of direct sunlight and diffused sunlight. So the contribution from direct sunlight is given by E cos pi, E cos theta, where theta is the angle between the surface normal and the position of the sun in the sky, and E is the maximum amount of direct sunlight. So I will show it here. So here what is happening? So if you want total, you want, so that is E cos theta plus ED, where ED accounts for the diffused sunlight. ED means diffused sunlight, and E cos, so that is direct sunlight, maximum amount of direct sunlight. E is direct sunlight, and that is the angle between the module and the sunlight, and E is the diffused sunlight. So that will give you easy. That will give you the easy. So here you can observe here. So what is, so this is the pyranometer. So this is the flat surface. We have placed it here on some arrangement. And here you can see the sunrise is directly coming on par. So it is measuring this, and diffused due to some water vapor. So here it has come like this. So because of water vapor, it has diffused. After diffusion, it came again here. Because here also this sun rays has traveled like this, and it has changed its direction because of diffuse, because of that clouds. It has passed. So it will measure both this direct and also diffuse due to different regions. So pyrheliometer is a different case. See here you can observe it will only take the direct sunlight. It will only measure the direct sunlight. So that is tube, blackened inside, alignment, indicator, thermocouples, black absorber plate, insulation, temperature component. Okay, for that you need some arrangement. Electrical readout. Here we'll be having a readout. Two-axis tracking mechanism. So this is a two-axis tracking mechanism, not a single-axis tracking. So this is to measure direct sunlight. So it is a device that measures solar irradiance coming directly from the sun. That's we know. So this year also, these equipment were also traditionally used to measure the climatical observation. So this is actually it look like. So here it will absorb the direct sunlight and it will give the only the energy, direct energy of the sun. So here also that is direct solar radiation E is given, and that is E is equal to E plus E diffuse, E plus diffuse. That we. So here you can see. So it is only taking direct radiation. You can observe. So direct sun rays only it is taking. If you go back and if you observe that aeronometer, it is taking the direct, it is taking the diffused also. So this is the main difference. Okay. And after this sunshine recorder. So number of sunshine hours it will take. So sunshine recorder. It is a nice, very good, beautiful looking glass sphere. So it is supported just like a globe on your table. Okay. World globe you will have might have seen just like that. It will be having some support. And card support again, sunshine card, and leveling screw to change the alignment, lock nut, low spear cap. So upper clamp and lower clamp both will be having, checking nut, sub base. So this is actually sunshine recorder. So this you can see. So this we are putting. So this will give the number of the hours in a day. And so it is a meteorological instrument used for recording the number of hours throughout a day. So this is because total day you will not having the sun, some because of clouds, some reasons you will not get. So for that finding the purpose, you are going to use the sunshine recorder. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.